Thank you, James, for your kind introduction, and good morning, everyone. My name is Yoichi MAEDA of NTT Japan, and I'm now serving ITUT as a SG15 chairman. And I'm very glad to make a presentation on behalf of the listed co-authors. And in Kyoto Symposium, Dave Faulkner had a good presentation. I hope he enjoyed the cherry blossom in Kyoto. And my title is Energy Saving Checklist, and it is a brief report on a preliminary study in ITUT SG15 on access network transport. So, what is the energy saving checklist? I have learned a lot of things from Bernard's presentation, and I'm very glad we are not alone to study about the checklist, and ETSI has already started the same kind of discussion. And energy saving checklist is a tool for assessment of existing and new ITU recommendation in the light of the climate change. And as an initial document, our study group, Working Party 1 management team produced first guideline on energy saving in the access network by the rapporteurs and editors. And if you access the ITUT document, TD 2288, you can find the initial technical report on this energy saving checklist. And also the checklist is a set of the questions related to the energy saving in network. And the first response was made by our study group to the TSAC. And this slide shows the estimated distribution of global carbon dioxide emission from ICT. And this data is taken from the Gartner research paper, as I listed at the bottom. And we have learned about 2% energy consuming is for our ICT sectors. So the point for our study is left-hand side, and you can see the fixed line telecoms 15%. So how can we reduce the load of the 15% from some 2% for the ICT sectors? And what are the benefits of energy saving in telecommunication? We have already learned a lot from the previous speakers, and first one is reduction of the cost of energy. The last slide of the banner shows if we use about 100 watt equipment, it costs around 100 euros a year. So if you have a small network termination box, and if it is consumed around 10 watts, you have to spend about 10 euros a year just for the putting the equipment. So reduction is not only for the end customers, but also the operators. Operators have to implement the line termination equipment to provide the accesses. Also, reduction of carbon footprint and where the electricity is sourced from the fossil fuel. Also, reduction of the size and the cost of the backup battery and generator. Operators have to support the lifeline services during the power outage. So the reduction of the power consumption helps the smaller size of the battery and load of the generators. And also, lower power makes a new technology solution feasible. And in Europe, line-powered remote node with fiber copper using a XDSL hybrid solution need some more intelligent mechanism to provide up to the 100 megabit to the home. So far, the SG15, and SG15 has a mandate to provide the standards for the transport network infrastructure, and we are a lead study group on broadband access network technologies and optical core transport network and technology in ITUT. So regarding the broadband access technology, as I said before, as a potential for the large energy saving in the end devices, if you consume the 10 watts and static says about 1 million or 1.2 million DSL user in the world at this moment. So it's equal to the about 20 medium-sized power station. So higher speed access system will become a dominant network for your infrastructure to support your NG and new services. Regarding the transport core network technology, in this core network, we can carry the aggregated traffic, and we can share the devices across whole the population. So the energy saving are possible, but energy saving per customer is not is very small. So access part is more give us a more good big impact. So this slide shows we call the reference diagram to define the access system. So left-hand side is a network and line termination located in the network offices, and fiber or copper is used for the transmission path, and in the user side, network termination terminates access signal and provides several ports for the users, such as Ethernet, voice over IP, or several video signals terminals. But in current ITU, our study group only define the transmission interface. You can see SR or RS. It's a sender receivers. So our current standards is focused on the transmission interface to describe the signal passing through that interface to realize interoperability between the vendors. But regarding the implementation of the yellow box in the network side and the user side, it looks like a black box. So, and especially the black box at the user end consume most of the energy. So it is some part out of scope of the ITU, so we have to liaise with other standard body, such as IEC, ISO, and IEEE. Also, regional policymakers, such as the European Commission, we need to liaise with their work to define the function and the target for the reduction. And what is the power consumption of SG15 broadband access technology? So as I already before, in SG15, one of the most popular products are the ADSL, VDSL, and BPON and GPON, optical passive optical network system. So those systems consume around 3 or 7 watt per customers. And the user port typically add to a further several watts, 5 watts, include router, firewall, and normally the 4 Ethernet, Wi-Fi, and voice over IP port. And as I said before, it's not a real area for ITU standardization, so we have to liaise, in this case, IEEE about Ethernet port. And the current system is basically designed as always-on technologies. So standby mode, power down mode, and sleep mode should be considered. So this slide shows a broadband subscriber forecast provided by Urban Research. And as you can see, the number of the subscribers double every 5 years. It means the power consumption double every 5 years. So as a summary, is the broadband market likely to double in the next 5 years? So if the energy consumed per line is half in this time scale, we can maintain the emission at the current level. So this is a challenge to reduce energy consumption by more than half every 5 years. But the half is just an example. And this chart shows the relation between the power and the speed of the fiber access system. So at the bottom, if you know about quantum physics, the red line shows the quantum limit at the optical signals. So the pick-watt order is required to identify the bit. But if you implement a receiver, optical receiver, bottom green line shows the practical receiver requires a microwatt order per bit. But once you implement this function into the NT and line termination box, you have to use several watts. So there is a possible reduction and efficiency improvement more than 100 million compared to the quantum physics theories. And this chart shows the relation between the transmission rate and the power consumption over time. So every year, we developed the sophisticated system to give you a higher access system. But also, it increases the power consumption. So if you increase the access speed 10 times, roughly 10 times power will be consumed. So can we save the power while increasing the speed, as I showed the green line? So it is our future issue. So refer back to the energy saving checklist. I just, to conclude my presentation, I will show you some example. So current energy saving checklist has two parts. One is a general, and the other is mitigation. So example question is, does this recommendation foresee the development of the device or networks that will require the consumption of the electric power? Yes or no? You can check. And will the implementation of this recommendation change the power requirement of existing device or network? You have to check. And if yes, please assign approximate score to the significance of that recommendation for climate change. So as an example, this chart shows the categorization of power consumption and the market potential for the IT recommendation. So if you have your equipment standards has related to the market, for example, 1 to 10 million users in 10 years, if the equipment consumes the power up to 10 watts, it's categorized class C. But if you can reduce the power, one of the tenths, it improves the category into B. This is a kind of example. And another example related to the mitigation, that the recommendation consider or enable the lower power energy consumption of the technology or network, for instance, by enabling the multiple power mode. And if so, how well does recommendation perform the action of the reducing the energy consumption? So in this case, is power saving mandatory or optional? This kind of consideration should be made in the future standards. Also, SG15 has revised the existing old question for the next study period to include aspect on the climate change issue. So in future, in the next study period, each new recommendation should identify the impact on the climate change, how it contributes toward a measurable reduction in the emission of the green gas. So that's the summary of my presentation. So please visit our website to get the TD 288. It's a fast draft stage of the document, and can other study group use it as a model, or can ITU work with other body to agree worldwide target and check compliance? So I I look forward to contribute to this activity, increase the collaboration with other standard body. Thank you very much.